example. Using excuse me, pipelining. First, we're going to go through one instruction at a time, pipelining, and second, we're going to see what the improvement is if we have a multiple issue pipeline where 2 instructions can be issued at a time. So here's our code. We're going to assume full forwarding, so that means the only hazards are a load use. We're going to assume predict taken branch predictor and no delay slots. So we have delay slots when instructions are allowed, whatever, like the instruction before a branch would go after it would be rearranged to be after it, so it can go all the way through regardless of the branch. But instead of doing that, we're going to have a branch predictor. So here's our code, and the way it runs, just for this example, is that this first branch is not taken, then taken, and this branch is taken. And so this would be our code, the actual instructions we want fetched, or that should be executed. We do the load word, the add, the branch, the first time it's not taken, so we do the add I, the load word, the branch on equal. This is taken, we come back up, and it's not taken, we go down to here, and so on. So here's our code. First, load the load word. Second, load the add, no hazards there. Third, load the branch. Since we assume it's taken, the fourth instruction loaded would be this store word, because we assume all branches are taken. Then, in the next cycle, when this branch is executing, we find out we shouldn't have loaded that, so we zero it out and load the add I. Next, we load the load word. It needs the new version of R2, but since we have forwarding, that's not a hazard, so this we're going to forward this to this load word, which needs it here. So we do the load word with no hazard. Next up is this branch. There's a hazard here because the result of this load word is needed for the branch, so that's actually a load use. So in the next cycle, we're going to put a bubble in and stall this branch. And then this is taken, so the next, and it's assumed taken. So the next one is this branch, no hazard there. Then again, assumed taken, so we have this, again, no hazards, and it goes through. So now let's see how this would work on a multiple issue, but only one memory instruction can be fetched. So we can fetch 2 instructions, but only one can be a load word or store word. So we're going to start with these 2. How nice. In the next, we're going to fetch the branch, and then since we assume that the branch is taken, we're going to fetch the store word next. So these 2 move forward. In the next one, we're going to fetch this store word. So now we've fetched 2, and then there aren't any more instructions. Then we find out we mispredicted the branch, and this thing is in the execute, so we zero out this, and we zero out that. So now we have a bunch of knops running through, and we're back up here, and we load in the add I and the load word. And again, this isn't a hazard because the ALU is going to be calculating this address at the same time, it's adding 1 to R2. So this actually will get the right R2. The next one, we are going to load the branch and go up to label 1. But there actually aren't any, when we go up to here, the only load available is this, and that would be a hazard because we would need the result of this add I. So there aren't any loads we can load. So it's a branch and a knop. We assume it's taken, and so we load the next branch and a knop because again there aren't any memory coming up. And actually though, since we know this branch is taken, couldn't we put the store word in here? I've recorded this so many times because I keep getting it wrong. I'm really tired of recording this. Keep getting it wrong, but I think it would load this store word. I might have just saved myself a... Alright, so we do it like this. Alright, and then this one, in the next one we're going to put this store word. So yay. So we get this, all of the just fixing it. So yeah, I think because it assumes it's taken, you can so instead of 15, we're done in 11. Right. So I changed what I originally had because you can, since it assumes it's taken, you could load this store word at the same time you load the branch because you assume the branch is taken. Just like up here. So that's cool. So not as much speed up as you would have guessed, but speed up nonetheless. So that's that.